Welcome back to another one. What did the pig say on a hot day? I'm bacon. Only works with an Aussie accent. Okay, today is boom. There it is. We are talking about solving simultaneous equations. Now, what is a simultaneous equation? Okay, this is normally what gets people confused. But let's break it down. Okay, if we're talking about solving a simultaneous equation, simply what that means is we're solving two equations with two unknowns with one set of solutions. Okay, so often later on you'll find out when you're drawing lines is that it's the intersection point. So we'll often call this the point of intersection. But for now, I want you to think whenever you see two equations with two unknowns, simultaneous is going to be the way, it's going to be the method that we do to solve this set of equations. Okay, there's two main methods. The first one is the substitution method. This one I find personally easier. Now, the example that I gave kind of makes it a little bit easy too, but we're going to do this regardless. I'm pretty sure I wrote the question wrong, but let's try that out. Yeah, okay. Let's try it out. So this substitution method solves simultaneously. You guessed it, we're going to substitute. Okay. Now, the way that we tend to do this is, let's call this equation one, we'll call this equation two. This way of kind of labeling things is often very helpful for when you're trying to show your marker that you know what you're doing. Now here, what's nice is I've isolated an unknown. So I can see I've got a y here. I can see that I've got a y there. And so all I really need to do is I can say that I'm going to substitute equation number one into equation number two. So the way I'm going to do that is equation one is instead of every time I see y, I'm going to replace it with x squared. But I'm going to do that in the second equation. So instead of writing y equals to x plus 2, I'll do this in a different color. Instead of doing that, I'm actually going to replace y with what we said y was, which is x squared. Okay, so we've just substituted that out. Now, generally, you always want to sub something from the first equation into the second equation. And it's always nice when you've got a singular unknown, like a y. So if it's 2y, you want to remove that until you're left with just y. But in this case here, it's nice and easy. So we've substituted that out. I've got this now. How would I solve something like this? I need to recognize that there is a squared term, a non-squared term, and a, what do you call that? A constant. So what I need to recognize is that's actually a quadratic. So I'm going to put it all to one side, let it equal 0, and try to solve that way. So this is going to be x squared. I'm going to take away the x. I'm going to take away the 2, and I'm going to let it equal to 0. And here I would just PSF. I can see that x would be x minus 2 and x plus 1. Going back to our factorizing, and I can see from here, let's take it up a little bit. X would either have to equal to positive 2 for the first one, or negative 1 in the second one. So those would be our two solutions. But not only do we need to know what x is, we also need to know what y is. So for y, we're going to substitute each value. So I will write this. When x equals to 2, or I'll say what at x equals to 2, y equals 2, and I've got equations for that. I can see that y here equals to x squared. Or I could use the other one. I can say y equals to x plus 2. So in this case here, it's going to be x, which is 2, plus 2, which equals to 4. And just to prove that I can use either one, you can substitute it into x squared, because 2 squared is also 4. So if I substitute it into this one, that's fine as well. It's just maybe plus 2 is easier for you to calculate. And again, at x equals to minus 1, I can see that y is going to equal to minus 1 plus 2, because it's x plus 2. And then I can see here that my y value would be positive 1. Okay, so the way that we would write our solution in this case is each one of these is a coordinate. So that means one solution is I can have x equals to 2, y equals to 4. That's one solution. Or I can write x equals to 1, y equals to, or sorry, x equals to -1, y equals to -1. That's the way you can write your solution. Or you can be old school and just say x equals to 2, y equals to 4. That's one solution. And then x equals to -1, y equals to +1, and write that as your second solution. Okay, so it just means that these two equations, they would both work if x equals 2 and y equals 4. Both of these would work, and it will also work for x equals -1 and y equals -1 for that one. Okay, now the other method is the elimination method. And so what you want to do here is you kind of want to cancel out some unknowns, right? Because it's always impossible to solve an equation with two unknowns. So the way that I'm going to do this is here, nothing really lines up. The 3 and the 4, they don't really line up. And the y's here, they don't really line up. So I'm going to have to change them just a little bit so they kind of work in my favor. So again, I'm going to label this equation number 1, equation number 2. And I'm going to go, okay, I like this y. Whenever you get a singular letter on its own, it's kind of like it helps you out. So I'm going to say, I want this to end up canceling with that one up there. So what I'm going to do is I'm going to times the bottom one by 2. And I'll show you what I mean. So I'll go equation 2. I'm going to multiply it by 2. So it's going to be 2 times everything. So in other words, if I double it, 4x times 2 becomes 8x. Y times 2 becomes 2y. And then 24 times 2, don't forget to times the other side, equals to 48. Okay, I'm going to call this equation number 3. Okay, it came from equation number 2. Now, equation number 1, just as a reference, equals to 29. And this one here was equation number 1. Now, my goal is to eliminate the y's completely. And the way that I'm going to do that is I'm going to actually plus them to each other. I'm going to add them to each other. I'm hoping I'm making the right move here. Yes, I am. So if I add them together, I'm going to go equation 1 plus equation 3. What I'm going to do is I'm just going to add them together. So I'm going to take a look here. What's 8x plus 3x? That gives me 11x. I'm going to see here what happens when I get plus 2 plus minus 2. That's going to give me 0. And then I've just got my equals, which is 48 plus 29, and that's going to give me 77. And that's quite nice. I can see here that x will equal to 7. But I also need to remember, in this case here, I don't just need the x, or in all the cases really, I also need the y. So the way that I'm going to do that is I need to find y by sub into, and I'm going to sub into 2. You can sub into 1, you can sub into 2, you can sub into 3. Any equation works. You just have to substitute in. And this is kind of why I like the substitution method. It's a lot, you just substitute. This one you got to do both. Okay, so we found what x is. Let's substitute into this one. Equation number 2. And I can see here, equation number 2 looks a little bit like this. 4, and instead of writing x, I'm going to write 7 plus y equals to 24. And from here, all I'm going to do is 4 times 7 is 28 plus y equals to 24. And then I'm going to solve for y, and I'm going to do that by minusing 28 to both sides. So I can see here that y should just be -4 because 4 minus 28 is -4. Again, that there becomes our solution. Therefore, you write it together, x equals to 7, y equals to -4. That's your solution, or if you want, you can write it as a coordinate. That's fine as well. There you go. And I think that is it for this video. You've got 2 methods. Knock yourselves out. Have fun and see you later. Okay, bye-bye.